Hello, this is the Capstone project, and it has two main files. One is the hypertuning and one is the AutoML. AutoML deals with the AutoML way of building the model and deploying it. So I'm importing all the required things, creating an experiment and a workspace. Experiment name is Capstone AutoML experiment. Attaching a cluster with 4 nodes, and this can be seen over here in the cluster. This is the AutoML cluster with 4 nodes which has been created over here, and after that we're getting the data from the UCI repository, machine learning repository, and this is the data regarding a maternal health risk data. Some of the data elements of this is like the age and the BS, body temperature, heart rate, and finally it predicts the risk level, which we will be predicting in this. And this is the risk level which we will predict. This is the AutoML setting with an experiment timeout of 45 minutes, max iteration 5, cross validation 3, and the primary metrics for this one is accuracy. It's a classification task. Here's the label column, which is the risk level, which we will predict. It's on auto, and I will enable the OnX model in case I have to save the model in OnX version. Is the run. I'm submitting the job, and this shows me the run status. It says completed as of now, but on the screenshots you will see that it ran. And the best model out of this is the voting ensemble. So we can go over here in the experiments, and in the experiments we go over here, models. Here's the best model, which is the voting ensemble, which is at 81.752 or 81.8% accuracy. And the thing which feature that mostly impact is the BS feature. Okay, and we'll see if this provides a better accuracy or the model run using the hyperdrive provides the best accuracy. This is the status, and I'm waiting for the status to complete. Wait for the completion. This is the whole history. It goes through all 38 or 39 models and 38 models. It comes back with that. The best model has completed, and it's printing all the model details over here. The accuracy is there. Next, I'm printing the path for the model, what path exactly it has followed. Next is the deployment, but before deployment I'll walk you through the model use using hyperparameter. So in the hyperparameter you import everything, all the required things, and the experiment name is Capstone Hyperdrive Experiment. So if you go to the experiment, you will see the second experiment, which is the Capstone Hyperdrive Experiment. And then creating the cluster for this one. I used a different cluster. I didn't use the same cluster, so the cluster name over here is the Hyperdrive cluster. So if I go over here and go to the cluster, this is the cluster I have used. Okay, next is the data set, is the same data set, and the way to access this is in the same way. Prediction will be the risk level. And the entry script over here is train.py, which has a logistic regression in it. The early termination policy used is bandit policy, and I've used a random sampler, which I'll provide the details in the README document. So we are going for accuracy, total run of 20 and concurrent run 4. Okay, submit the data, submit the run, and the screenshots are there are multiple screenshots while it's processing and all those things, so you don't have to worry about that. These are the multiple stages of screenshot where it's running and all those things, so I'll submit this in the readme document so you will have it. So the run is completed and we see the accuracy about 60% accuracy on this one. Okay, so I'm getting the status of this, and then at the end I get an accuracy of 60%. So I'm not deploying this model. I'll deploy the model from AutoML. So go back to the deployment in the AutoML. Here's what I'm registering the model. Next, I'm just printing it, the version of the model which got implemented. And here I'm providing the environment variable. This has all the details. I'll provide the file so you can see what it is. And the scope py is the entry for this one, for the configuration, interface configuration. And then eventually the model is deployed through a service, and here it shows the deployment, and you can see it in the endpoint. The model is deployed, so endpoint, it is status is healthy, and then this is the REST endpoint URI, and this is the application insight enabled with the URI over here. So we check over here if the URI matches or not, Swagger and scoring URI. So I'm sending the request through the URI. Okay, scoring URI, this one. And this, if we look into the data, this should return us high risk or whatever it is. So this is the test data which I have provided. So if you go to the data set and we explore it, I took the first row as the data sets 25, 130, 80, 15, 98, 86, and it comes out to be high risk, and so it has come out to be high risk. That is perfect. And then getting the log of the service as per the project requirement, and then deleting the services and the models. Okay, so that's the total project over here. Let's go back to this one. So I'll just quickly show you here's the AutoML model dataset. You saw the two experiments. There's no pipeline. Environment we don't need. Model, there will be only one model which has the voting ensemble as the best experiment or best model, which you saw that, and these are the multiple explanation for this one. Okay, details, metrics, and all those things are there. So this is the whole project, and I will document it and submit it. Thanks, bye.